Hey, you guys, happy Monday. Here is the lesson. If you missed it, or if you just want to listen to me tell you about it, this is what we're doing today. We are finishing up our kind of short introductory unit. We're modeling, analyzing molecules, telling me about atomic composition in them. Remember that this is building, and we will continue this skill until we're talking about molecules interacting with each other in chemical reactions. That's kind of where we're building towards here. Right now, we're just like, wait, what are molecules? What are atoms? How do they work? And then we can build all the way up to chemical reactions. So today is the last day where we're just doing the molecules themselves. We're going to start chemical reactions soon, tomorrow. And so at the end of the day, you do have a graded quiz. Please make sure you take that. It's the last slide below. Okay, so here's your do now. Here's a picture down here of this molecule. Is it a simple or extended molecule? Simple molecule, extended structure. Tell me what it is and how do you know? That's important that you know how to tell the difference. And then look at these three formulas: C2H2O2, C2N4O2, C2H4O2. Which of those three fit this molecule? Tell me how you know. So pick one. You can call it A, B, or C, or write out the whole thing. And tell me how you figured that out. Okay, so I'm going to keep going. You can pause me and answer that question. I have a scientist of the day for you. September is, so I'm making this during September, but I didn't know, but I found out today that September was a Deaf Awareness Month. And so I have one of the many deaf scientists, one of the few that I have Science of the Day prepared for already. I'll share that with you today. We're going to do a couple of live questions that you're going to answer in the chat during your live class. So if you miss live class, then you can answer them while you're going. I'll show you the breakout room practice with analyzing molecules, and then you're going to have independent work practice before your final quiz. So it's basically a lot of the same skills. Modeling, I'll actually have you guys modeling today, answering questions. What's the atomic composition? Match the equation with the formula, things like that. This is Johanna Lucht. You might think about how old she is. So she's born deaf. She was born in Germany. And in Germany, when she was born, there weren't a lot of resources for her. Her family moved to Alaska. There are remote programs for deaf students. She went on to get a bachelor's degree in computer science at the University of Minnesota. And she started working at NASA, which is so cool. She got an internship, which is like an unpaid job at NASA. And then she was offered a job after that. That's why people do those unpaid internships. And then a few years ago, she was the first deaf engineer to have a role during a flight of a NASA rocket. So she managed the flight GPS data. So GPS is Global Positioning System. Where is the rocket as compared to everything? She managed that, which is really cool. And this is like the picture of her during that time. This is her little control center. And so I took a quote from her because I thought this is really cool. I just proved that a deaf person can participate in a control room during a manned aeronautics mission. So why not a deaf astronaut in space? I like that very much. I like this idea. I hope hope she inspires other people that just because you're differently able doesn't mean that you can't be a scientist, and two, do the exact jobs that you want to do in science. Maybe being in control and an engineer during NASA launches is just super cool. So that's good to know that that is happening. Okay, so quick reminder about how to read a chemical formula. We started this last week, so I'm going to just walk through the slide real fast. This molecule has 5 atoms: 1, 2, 3, 4, 5. 4 are white and 5, and one of them is black, the middle one. I'll move myself out of the way here. While there's only one atom, when there's only one atom of a certain element, we don't write the number after the letter in the formula. Think about H2O. There's no number after the O, which means there's only one oxygen atom in a water molecule. So here we're going to write C. We don't write a number. If it helps you, you can imagine if there's no number, then there's like a secret little 1. Sometimes if you were in my classroom and you weren't sure, I'd walk by with my pencil, take it behind my ear, and put a little 1 next to it. And you go, that means there's 1. So if there's no number, it means there's 1 carbon atom right here. Then If there's more than one, then we write the letter, and then we put the number after the letter. So in this case, there's H's, there's C's, okay, and there's H's, C's, and H's. We write C's and H, okay, no C, or sorry, only one carbon atom, so we don't write any number. But there's 4 hydrogens, so we put the 4. And then we put these together. So they become carbon, CH4. You won't call this carbon hydrogen or anything. This as a has a name. This molecule is called methane. So as a hydrocarbon, I guess you would call it, is one of the many hydrocarbon molecules. Okay, so I want you to practice these same rules. Okay, so you've seen this molecule before. I want to know, what would the chemical formula be? So pause it right now and see if you can figure it out. What are the letters? How many of each? Remember, maybe write down the letters and then write down the numbers after it. So pause me, check yourself to see if you can do this. Okay, did you get H2O2? There's H's and O's. If you wrote O2H2, that's fine. When you get into high school, college, you will learn the rules that determine which letters we put first. There are rules. You would never write this O2H2 if you were, a professional scientist. You would know that H would come before O, but the reasons are really more, they go beyond what we can learn in 7th grade. And so if you wrote O2H2 in my class, it means the same thing. Excellent job. Okay. So here's another one that during live class, I'm just going to have people throw right down in the chat. So if you missed that part, think about this right now, pause and make sure you can answer how many atoms are in this molecule. I can count them for you real quick. 1, 2, 3, 4, 5, 6, 7, 8 atoms in this molecule. Okay, this question is, how many elements, not atoms, how many elements are in this molecule? I'm waiting because I want you to pause it and answer the question and then hit play again to see what the answer is. Okay, remember that one of the ways we show different elements is just by different colors. So how many different colors are there? There's white, there's blue, there's black, and there's red. There's 4 elements in this molecule. Which of these, A or B, is an extended structure? I think that should be relatively easy. This looks pretty simple. This looks big and long. There's a pattern that repeats over and over. So this is the extended structure, A. And I want to make sure you know why. And it's because of that subunit. It has a piece that repeats over and over and over. In this case, that piece is this little piece right here. You can see it. This is the red, black, red. Red, black, red is an oxygen, a carbon, and an oxygen. That is carbon dioxide. This is a model of dry ice, of solid carbon dioxide. It's an extended structure because it has a subunit, CO2, that repeats over and over and over and over until you get this huge structure, molecule, if you want to call it that, but we kind of differentiate it usually from a molecule like this. Okay, so those are just some quick warm-up questions. In breakout rooms, students are working on these 3 slides together. There's some modeling involved, there's some multiple choice, and some other questions. So I'm just going to run through them, and I'm going to expect that you are going to do them. Basically, if you missed live class, then you're going to do these just like you would do your independent work. So move myself out of the way a little bit. I guess I can't. Okay, so bleach is sodium hypochlorite, NaOCl. Using, so first of all, you're going to list these elements. You're going to tell me if it's simple or extended. And then you're going to model NaOCl with the atoms I gave you. You're going to drag these over and make the model. Okay, so now I have a blue circle here. I want you to take that blue circle and put it around the extended structure, A, B, C, D, or E, made of one type of atom that repeats. And I want you to take this green box and put it around the simple molecule that's made of different types of atoms, different elements. Okay, so you got to look at A, B, C, D, or E and say, this describes only one of them. Which one is it? This describes only one of them. Which one is it? Okay, then for the last one, you're just doing straight modeling. A simple molecule, SO2, which, how do you model that over here? And then an extended structure, NaCl. Can you draw, can you model an extended structure? That means taking NaCl and showing me the repeating subunits. That would be table salt, by the way, NaCl. Same stuff you stick on your eggs. Okay. So I would then have gone over these really quickly with some students, with everybody in class as they come back from their breakout rooms. And then independent work is basically just more of that. I want you to get really good with these modeling. Also soon, I think tomorrow, we're going to be introducing our portfolios. And I want you guys to choose one of these models to share, because it's cool how you guys are modeling with these things. You know, if we were in class, I'd be able to model with like Legos or something. Heck, go grab your brother's Legos and model and pretend like, get a red one, say that's oxygen, and a white one is hydrogen, and make water molecules, make all these other ones, okay? So the next 6 slides are practice. After that, the last slide is your final quiz for the mini unit. Okay, it looks like this. Do not forget to do it. Definitely do it. Okay, so again, hydrogen cyanide, HCN, is a very poisonous molecule. What are the elements? Just list them here. And then model it using these atoms. I can show you that real fast. Let me go up here to the, yeah, this is the breakout room. So how you would model this, just so you know, you're looking for Na and O and Cl, something like that. As long as you show them touching. If you really, really want to, you can separate them and draw lines between them. I don't know if you want to do that, but you can. Either way, now you're showing molecules. Take all that back. That's what I mean. So if everyone else was going to get an example. So here is baking soda. Let me wait for it to load again. Here's baking soda. Sodium bicarbonate is the name of the molecule. List the elements. Drag the atoms over here to model it. Vinegar is a solution of acetic acid. What are the elements? Drag it over here. And one more, just because I wanted to be rude. Diamonds. Diamonds are extended structures. One diamond is basically one big molecule of pure carbon. So what molecules do you need? Model them over here. By the way, for any of these, if you don't have enough, you need 3 of something, and I'm only giving you 1 of each, so copy and paste. That's how I expected you to do that. Circle the molecule with the formula F2. Which of these is F2? Circle it. Which of these is CH2O? Which of these matches that formula? And then what elements are in this molecule? Look them up if you need to. Remember, the letters are capital, lowercase, capital, lowercase. This is a CL, not a CI. This is not AI, it's AL. List them here. There's only 2. Okay, that's it. You answer those questions, you're warmed up, you take your quiz, you ace it, you get an A in science class, and everybody's happy. Thank you guys, and I will see you in class tomorrow on Tuesday. Goodbye.